Hello, my math friends. This is Mrs. Schlecht, and in this video, it's going to be a crash course into probability. All right, my friends, so you know that before we get going, there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision book. Remember, we're in volume 2. Second, don't forget your math notebooks so you can take those beautiful math notes and show all of your wonderful math thinking. Third, don't forget your pencils so you can take those great notes. And fourth, last but certainly never, ever, ever least, that positive math attitude. First, a little disclaimer, my friends. You'll notice that this is a crash course video. What does that mean, Schlecht? Great, glad you asked. So, unfortunately, our time is a-ticking together this school year, all right? So what that means is the entire topic 7 that's in our Envision book, all about probability, super cool. Unfortunately, we ain't got time for that, my friends. I gotta kind of shorten it down a little bit. So yes, we're still looking at Envision because there are some great pieces that we'll kind of pull out in some examples and things that we'll look at, but we're not doing the whole entire shebang, all right? We gotta kind of narrow our focus. So yes, we're talking about probability. Yes, it's something that's in your Envision book, but again, we're not doing the whole entire thing, okay? I hope that you'll be able to cope with that. I think you will. All right, my friends, so there's really just 3 lessons in topic 7 that we're really going to be focusing on, okay? So the first is lesson 7-1, and that just kind of tells you what probability is. Now, the key concepts for that lesson can be found on page 372. The second lesson that we're going to be looking at is also 7-2, which talks about this certain kind of probability called theoretical probability, okay? And those key concepts can be found on page 378. Lastly, there is lesson 7-3, and that talks about a different kind of probability called experimental probability, okay? And the key concepts for those can be found on page 384. So before we get into like super cool fun math, right, let's just talk some basics, all right? Probability. It's the likelihood that something will happen or the chances that something will happen, okay? How likely is something to happen? What's the probability, okay? So there's 2 different types, theoretical and experimental. Theoretical is like just the idea, okay? Experimental is like what actually happens. I know that might not make a whole bunch of sense, but let's think about this. Let's think of a die, just one little 6-sided die, okay? Now, there's 6 different numbers on that 6-sided die, right? Let's write those numbers down. So let's pretend we have a die, and just a little preview, we're doing this actually for realsies in class, so stay tuned, okay? Anyway, so we have 1, which is what's 1 dot, right? 2, 3, 4, 5, and 6. Now, the theoretical probability means that whenever I roll this die, each one of these numbers has a 1 in 6 chance of actually coming true, right? Because there's 6 different chances, there's 6 different outcomes, we can say here, right? And then each of these outcomes is just listed one time. Like out of these 6 numbers, there's only 1 1. Out of these 6 numbers, there's only 1 5. Out of these 6 numbers, there's only 1 3, right? So in theory, just an idea that if I were to roll this die, then one of these numbers, all of them have an equal chance of actually happening, right? It's a 1 in 6 chance because we're looking for one specific outcome out of a total of 6 different possible outcomes, okay? So we can roll the die in theory, and any of these numbers, it's likely has the same probability of being the one that, you know, we get from that roll. Now you're probably wondering, but how is that actually different from the experimental probability? And that's a great question. We know that that might not work out in life, right? If you remember, like kind of back a couple weeks ago when we used dice to talk about something else, Mrs. Schlecht was trying to roll, and I kept like getting the same number over and over and over again, right? Now, yes, these all in theory have the same likelihood of being the result once you roll that die, but the actual results could be quite different, right? Maybe I keep rolling, but for some reason I get 4 over and over again, then I get a 5, then I get a 2, I never get a 3, right? I mean, in theory, all of these have the equal chance, but in practice, when we actually do this experiment, when we actually have results, it might be a little bit different, okay? Remember, we're actually gonna be looking at this in class this upcoming week, where we can see that, yes, all of these have likely outcomes, but what will it actually be in real life? It might not be the same. All right, my friends, so let's kind of put these into practice, okay? So we're looking at page 384, and we're looking at numbers 4, 5, and 6, okay? So the story is our friend Kelly flipping a coin, okay? Flipping a coin. Could be a quarter, I don't know. Could be a dollar coin, could be a penny. I don't know. Could be a euro, could be a Canadian dollar. I don't know. It's just a coin, right? But there's heads and there's tails, okay? And she does it 20 times. And here are the results, right? So we have 20 different flips, and then the results. So H means that it landed heads up, T means that it landed tails up, okay? And there's a couple different questions. Number 4 is asking us about that theoretical probability, right? Now, in theory, there's only 2 options. Okay, so there's heads, there's tails, that's it, right? And theoretical probability for number 4 asks us, well, what are the chances that she's going to get heads? What are the chances that she's going to get tails, right? And in theory, it's 50%, right? Half of the time we'll get heads, half of the time we'll get tails, because again, there's only 2 options. That's it, right? So number 4, that theoretical probability, in theory, just an idea, since that coin only has 2 options, it should be 50-50, right? Half of the time it's heads, half of the time it is tails. But number 5 is getting towards that experimental probability, right? As we can see, it didn't come out 50-50. Let's see, how many times did she land, or did that coin land heads up? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 for heads. And now let's count our tails. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times tails was up. Let's talk about these 2 numbers, 11 and 9. When we add them together, we get 20, which makes sense because this coin was flipped 20 times. But in theory, we should have gotten 10 heads up and then 10 tails up, right? Because in theory, there's only 2 possible outcomes and it should have been 50-50, right? But did that happen? No, that's the experimental probability, my friends. This is the real life stuff that actually happened. So number 5 is asking us, hey, my friend, did it actually happen the way that we thought it would in theory? No. Of course not, right? So the experimental probability, remember my friends, is like the actual results. So when Kelly actually flipped this coin, 11 times heads was up and then 9 times tails was up. What number 5 is asking us is, hey, what's the percentage, what's the experimental probability that heads would be up? And there's a way that we can use this using a fraction, and then using that as a way to convert to a percent. So what we could do for this experimental probability is we can use a fraction. So what it would be in the numerator, what would be the top, is how many times a certain outcome happened. Like how many times did heads come up on top, all right? And then the bottom would be the total number of times that this experiment actually happened. In this case, the total number of times that Kelly actually flipped that coin, right? So 11 times heads was the winner out of a total of 20 times that that coin was flipped, right? But remember, we can actually write this as a percent. So let's look at this fraction, 11/20ths. So we have the fraction 11/20ths, right? And we can write it as a percent. Remember, percents are that relationship with the number 100. So as long as we have 100 in that denominator, we can figure out the numerator is that percent, right? So think to yourself, my friends, how do we multiply 20, or what do we multiply 20 by in order to get 100? We multiply 20 by 5, and that gives us 100, and we need to do the same z's up here. 11 times 5 is 55. What does this mean? What this means is that 55% of the total number of flips was heads up, right? Now, what number 6 is asking you is to compare those 2 ideas, right? That in theory, if everything was all perfect, it'd be 50%, right? 50% of the time heads would be the winner, 50% of the time tails would be the winner. But experimental probability told us that once Kelly was actually flipping that coin 20 times, it didn't work out to 10 heads, 10 tails, right? It was a little bit different. 55% of the time, it was heads. So what number 6 is asking us is, hey, well, what was bigger, that theoretical probability or the realistic, the actual, that experimental probability? And in this case, my friends, that experimental probability would be slightly higher because remember, theoretically, an idea would be 50% both ways, right? But it's actually 55% for heads being up. All right, my friends, that was just a super duper quick crash course in probability. I look so forward to doing some more like probability stuff together in class. As always, if you have any other questions, please let me know.